Hey guys, Trevor Reed here. For my project, I will be doing the CRJ200 hydraulic system. Um, the system is primarily used to power the flight controls and some other components across the aircraft, which I'll get into later. So, thank you, and I hope you enjoy my project. So, the CRJ200 has three hydraulic systems: hydraulic system 1, hydraulic system 2, and hydraulic system 3. Hydraulic power is provided by three independent systems. All systems operate at a nominal pressure of 3,000 psi, and they use synthetic hydraulic fluid Skydrol, which is actually highly corrosive and can produce severe skin and eye irritation. That's a little fun fact for you. Um, Systems 1 and 2 are serviced by ground service panels. They're located in the aft equipment bay or aft compartment. System 3 is serviced by a ground service panel located on the right side of the fuselage, all aft of the wing root. Each system has two hydraulic pumps, a main pump for normal power and a backup pump for supplemental power in case of an emergency or something like that. Systems number 1 and 2 main pumps are engine-driven pumps. System 1's engine-driven pump is driven by the left engine, and System 2 engine-driven pump is driven by the right engine. The System 1 and 2 backup pumps are electrical AC motor pumps. Both hydraulic pumps for systems number 3 are ACMPs. In system number 3, the main pump normally runs continuously while the backup pump is available during periods of high flow requirements, so probably takeoff, landing, stuff like that. Hydraulic system power, supply power is used to operate the rudder, elevators, ailerons, spoilerons, flight spoilers, ground spoilers, wheel brakes, nose wheel, all kind, and the landing gear, which is also pretty important, I think, for the extension and retraction. The rudder and ailerons are actually powered by more than one hydraulic system. That's just it's used as a backup again to prevent a loss of flight controls in case maybe you lose system 1 and you still have system 2 and 3. So when you have during total AC power in flight, pump 3B will be automatically powered by the air-driven generator when it's deployed. So with this, we'll get into engine-driven pump or the hydraulic system 1 now. Thanks. So here we'll talk about hydraulic system number 1 and number 2. So with number 1 system, they both, or actually both the systems, they both have engine-driven pumps, so pump 1A and pump 2A, and they also have both have two AC motor pumps, 1B and 2B. They each power, or actually, I'll start with system 1. Provides hydraulics for the rudder, the left and right ailerons, or left and right elevators, sorry, left aileron, left spoileron, left and right flight spoilers, and then left and right outboard ground spoilers. System 2 provides hydraulics for the rudder, left and right ailerons as well, the right aileron, the MLG downlock, assist actuators, left and right outboard brakes, left and right flight spoilers, left and right inboard ground spoilers, and the right spoileron. Systems 1 and 2, again, like I said, consist of an engine-driven pump, an AC motor pump, shutoff valve, reservoir, accumulator, pressure and return manifolds, filter, and ground servicing panels. Both the number 1 and number 2 systems share a ram air heat exchanger for fluid cooling. Again, the fluid from each system is not mixed with other systems as it passes through the heat exchanger. And there's a fan within that heat exchanger that assists in the cooling of the hydraulic fluid when the aircraft is on the ground. That way there's no overheating within the hydraulics and less room for air with that. Thanks. So talking about some of those components from the hydraulic system 1 and 2, we'll start with the engine-driven pumps. The EDPs 1A and 2A draw fluid from the respective reservoirs through firewall shutoff valves. The fluid's pumped at 3,000 psi for the applicable pressure manifold and filtered and distributed to the aircraft hydraulically actuated components. We'll now move to the AC motor pumps. ACMP provides a nominal outlet of 3,000 psi as well. AC motor pump 1B is powered from the AC bus 2, and AC motor pump 2B is powered from AC bus 1. Each AC motor pump is controlled by a separate switch on the hydraulic pump control panel, which is located in the overhead panel in the flight compartment. When when the pump switch is set to auto, the pump will automatically start under the following conditions. The IDG2 must be operating for hydraulic pump B or 1B operation. IDG1 must be operating for hydraulic pump 2B operation. IDG1 or IDG2 must be operating for AC and P 3B operation. Then the flaps are out of the 0 degree position, so not up. From there, we'll move into the hydraulic shutoff valves. These are electrically operated, normally open. The hydraulic shutoff valves are installed in the suction lines of the engine driven pumps 1A and 2A. During an engine fire condition, the corresponding shutoff valve of the motor is closed when the engine fire push switch is pressed in or on. The valve position is indicated by ICAS. The reservoir for System 1 and 2 reservoirs are storage tanks that hold a reserve supply of hydraulic fluid for the respective systems. These reservoirs are partially pressurized, so they're mainly used for an emergency situation as well. The accumulator is installed in each system and stores hydraulic pressure. The accumulator is charged with nitrogen and is used to dampen pressure surges and to maintain system pressure during momentary system demand increases. So that's pretty much the sum up of those components that are actually within all three hydraulic systems. So talking hydraulic system 3 consists of the same components as system number 1 and 2 that I mentioned previous, with the exception that the number 3 system actually has 2 AC motor pumps and no engine-driven pumps. Hydraulic system 3 provides a nominal pressure 3000 psi, like I've said, to the ailerons, elevators, rotors, spoilerons, landing gear actuators, inboard brakes, and the nose wheel steering system. The number 3 hydraulic line passes through the wings, and it's cooled by the fuel. I've got a little diagram here that I can show you that shows just exactly how complex these systems are. They're pretty hard to follow, but the more you look at it, the more it kind of makes sense. The AC motor pumps on the hydraulic 3 system are controlled by switches on the hydraulic control panel. The system pressure is normally maintained by pump 3A, which runs continuously when selected on. So in normal operations, with the 3B pump switch in auto, pump 3B operates during takeoff and landings, while pump 3A does everything else. Pump 3B is automatically powered from the ADG bus when the ADG has been deployed, and it's independent of the flight compartment of the 3B switch setting. But that pretty much does it with system 3, so we'll move on from here. Thanks.